first speaker for the session, none other than your favorite celebrity. We are just clicking the pictures. So Dr. Uday Devgan to talk about the future of intraocular lenses using the AI and machine learning. Let's see whether we don't need to probably send them for any of the.
So I have a video. Have a video file.
Thank you.
It's just a single MPEG file, no PowerPoint. As you know, I like to make videos. So even my presentations are just one video. That way, nothing to click, and always, American style, always on time. You ready? When we go to the other computer, you have the video file. Well, happy to announce that our group was issued a US patent last month for AI with lens calculations, keratofractive surgery, cloud-based computing. That's the video. Let's hit play. Put it back. No, go back to the beginning of the video. Very beginning. Go to 000, very beginning of the video. Go to the beginning of the video, not this. Let me do it here. Is this side?
Yeah, you can do it.
Okay, I'll take care. Let me take care of it then. All right, the future of lens calcs. This is actually a really important thing. So if you look at lens calcs where we are now, there's so many different formulas. It's first generation, second generation, third, fourth. Well, do not ever use first or second generation. Third generation, okay, but they only use K and axial length. Fourth generation is better with Haggis and Barrett and Holiday too, but they're all static. So anytime there's a new factor, a new formula has to be devised. What if you find out that there's a better way of figuring out effective lens position? So you want an evolving formula that's not static. And so Barrett Universal 2 is fantastic, but it's static. Evolving, as limited as will be Hill or BF, but evolving in perpetuity is going to be lattice super formula. So this is what we were involved in for more than 10 years. If you look at our website, IOL we registered in the year 2000, 24 years ago. So we've been involved in this project for a long, long time, back when I had no gray hair. So we definitely want to do evolving lens calc. So anything AI or machine-based learning, you want to be able to evolve it with time and not be stuck to a rigid protocol. Have you ever seen something that says out of bounds on your printout, out of bounds? You don't want to have any out of bounds. So the trick is you can't let AI run loose. You have to give it a tether. Today, if you are the very, very best, 80% of patients fall within a half diopter of your target refraction. So 1 out of 5 is a miss. So if 25 years ago, someone published a study that said, okay, different formulas work better at different axial lengths. And that kind of made sense. So you kind of sometimes use that today. Here's a big paper that shows 8,000 eyes using multiple formulas. And this may be a good starting point. And in fact, if you look carefully, it's what Barrett already does. So let me show you this one. In this one, we did from 2015, 9 years ago, we combined multiple formulas and did a novel way of plotting it in 3D space. Lens power calculations is not a plane, it's a convoluted shape in 3D space. And that's what you have to understand. So this was our formula 1.0, and you can see we use different formulas at different aspects of axial length, IOL power, and corneal power. And you can see this is that shape, and it's not perfectly flat or planar, it has a shape to it. And that's what evolves with time here. And so if you look at Barrett Universal 2, we'd have 60,000 eyes through Barrett. You see these breaks right here? Obviously, at different axial lengths, Barrett's changing the formula, doing a different formula. He hasn't published what the formula exactly is, but we have hundreds of thousands of eyes of his Barrett formula, so I can back calculate the whole thing. And so this is the graph of it all back calculated. You can see there are breaks here at various axial lengths. If you compare our old 9-year-old lattice super formula to the Barrett Universal, you can overlay the two graphs, and you can see there's a lot of commonality, but there's areas where it differs, especially here. So here's a paper that came out, which we thought was very interesting. So of the best static formulas, it was Barrett Universal 2. But look right here. At an average eye, every formula works great. It's the unusual eyes where the formulas start to differ so much. And so you say, well, I'm smart. I've changed my A constant. I've honed my A constant. That doesn't work. Let me tell you why. So first here again, at average Ks, everything works. The black line's SRKT. If you have unusual Ks, never use it. Adjusting your A constant is antiquated. That's such an ancient idea because all it does is raise all eyes up or all eyes down. That doesn't make any sense. You can't treat this hyperopic eye the same way as a myopic eye. It makes zero sense. So an A constant may have been good long ago. Again, short eye with a steep K, you can't treat it the same as a long eye with a flat K. They're totally different eyes. So you have to optimize the entire area. So not just one A constant. Here's an example of some of my patients, the tiny hyperopic guys, 21 millimeter, 20 millimeter axial length. Notice how I had to readjust my formula. So we crowdsourced big data. We actually now have 7,000 users. We have 1 million eyes of data. So I can optimize for a single surgeon, multiple surgeons in a group, or all surgeons in the library. And I optimize for 100 or 10 ranges of axial length, 10 ranges of keratometry, 10 ranges of AC depth. So I'm optimizing 1,000 different points. And you want to just optimize one A constant? Come on, that doesn't make any sense. That makes zero sense at all. So this is an example of where a lot of my patients are common here, but how do I optimize these ones out here in the periphery? The answer is AI. So remember this? Who was the best chess grandmaster of all time? Well, it used to be Kasparov till IBM Deep Blue beat him. Remember that? That was 27 years ago. And now, 7 years ago, Google AlphaZero taught itself chess in a few hours, beats any human 100% of the time. That's where we're at. That's 7 years ago. 7 years ago. So now we're far beyond that. So you can see here, if you look at some of this, most formulas are going to give you 80%, but you can actually get 90% or more if you're tracking your own outcomes and using our AI, which will give you your own AI formula. If you give us enough data, post-op data, put it back in there, it'll give you your own AI formula. So we take all these different factors, axial length, K, AC depth. What about posterior cornea? We can put that factor in. We can put in any factor you want, and then the calculation layers are here, and there's a predicted adjustment. And we use a tether or a leash. So the AI can only change the output power. You can set it for 1 diopter or half diopter. See this yellow band here? This is where our formula predicted you have to adjust for highly myopic eyes, long axial length. Well, that's the Wayne-Koch formula. Our AI came to the Wayne-Koch adjustment formula automatically. Nothing to do. And so this is the beauty of doing it through AI. And again, crowdsource mega data sets. You can even start with 100 eyes. If you give us 100 eyes, you can actually adjust your IOL calc AI formula, your own one, for free. And you can see all these previous studies that you think you're so important are all based on less than 100 eyes. So give us 100 eyes of data, and you'll be surprised. You can actually get great results. Here's an example of a high-volume surgeon of Indian origin like me in Florida. He was 82% with Barrett. Lattice 1.0 was 85. But if we use his own prior data, his eyes, his data, he's 94% on target. In my clinic, if I do cataract surgery and you are not on target, I eat the cost of the LASIK. I do it for free. But I want to stick with Barrett, something else. There's no way I'm over because this is timed. So how can we use AI? Here's Plus. Plus is our precision lattice universal super algorithm. And so this is, you can start with any backbone. You can start with Barrett. You can start with Holiday. You can start with Haggis. Start with anything. And then we'll apply our AI to it to give you the final outcome answer here. So we can start, again, with any formula you want. Apply our Plus to it. Our patents were issued last month. We are now starting to really publicize this and actually go over and fight people who are infringing on our patents. So finally, the last thing I'll leave you with is the self-calibrating, evolving ocular biometer. Think about this. You have an optical biometer in your clinic. You do some measurements. Okay, that makes a lot of sense. Then data gets sent to us automatically. We calculate, here's the best lens for you, for your patient. Done. We tell you that lens power. Then you do the cataract surgery, you select that lens, do the cataract surgery, and post-op, put the patient back on the autorefractor wavefront analyzer. The post-op data gets automatically sent to us. We already keep optimizing your algorithm. There's nothing for you to do. All done automatically in the cloud. And so this is the future. If you want to know what the future is, it's going to be a self-calibrating biometer, millions of eyes, integrated lens calcs, tailored to individual surgeons, and evolves in perpetuity. And that's it. And the future of lens calcs is Plus. So again, it's a novel method, used with any formula, patents that were issued in the US last month on 23 different claims, and you can evolve in perpetuity and forever. And this is the way that we're going to do future lens calculations. So that is my talk. The video, if you like this whole talk's on cataractcoach.com. So you can be static at 80% accuracy, or you can actually evolve and push to 90+% accuracy using AI. And again, in my own clinic, you can stop that. If you miss the target, it's free. The LASIK is free. Cool.
Thank you so very much, Uday, for an enlightening talk.
Sure.
And it's always a pleasure listening to you, whether it's on cataractcoach.com or, listening to you live in any of the meetings. Now, we are talking a lot about IOL power calculation using the AI-based technology. Do you feel there are any limitations to this technology usage?
Right. The big limit is the AI can come up with some crazy answer.
Yes. So that is one of the...
Here's how we prevent that, though. You can start with a backbone. Let's say you like Barrett or you like Holiday. Holiday calculation gives you 21.0. And AI, you can say, only is allowed to change it by half diopter. So from 21.0, AI can say, no, 20.5 or 21.5. But we can make the leash or the tether only half diopter. Or if I want to be more aggressive, I can make it a 1 diopter leash. But usually I just stick with a half diopter leash. Because if you see most of your post-op misses, if you were off by a half diopter, you'd be pretty close.
Yes. The second thing is we are having many patients who have undergone post-refractive surgery now,
Right.
So these are the huge chunk of patients which are going to be needing for cataract surgery. So how do you see whether these patients are getting that much of accuracy using AI-based platforms? And
That's a great question. So that's obviously a big need, and that's even less accurate lens calculations. But we
Yes.
have a separate AI for that as well. That we've not released for free. All the free stuff is at IOL calc.com. And again, that's a site we registered 24 years ago, but it's all available. Our ones for post-refractive, we are still keeping close to our chest right now. We'll wait and see.
Okay, now the common question, we'll take audience questions as well. We are running short of 1 or 2 speakers, so we have enough time for discussion. But the common question here comes is, are the optical biometers, gives us a rough value guideline to go about to superfine our, IOL power calculations on AI-based platforms, or do you feel that still a olden day immersion biometry is the way to look forward for this?
No immersion biometry. Use your current optical biometers, and the data input, you're going to use AI to come up with an answer.
Because now the current optical biometers also, say for example, either it's on Zeiss or Lenstar or whatever platform we are using, they have their own set algorithms, and most of them are getting incorporated with AI-based platforms. So there also comes a confusion which way you are going to go. So what's your take on this?
Well, time will tell, see how it all pans out. But as of today, there are multiple companies infringing on our patents.
Yes.
But our patents were issued about 1 month ago, and so we are now just ramping up. Talk to me in a year, I'll let you know.
Okay. Okay. We have a house full here. Any questions from the audience for Dr. Uday? Before we bombard in with some more other questions.
Yeah, don't be afraid of it. AI's coming. It's going to be amazing. Your life will be a lot easier. A lot easier.
Yeah.
Yes, please go ahead.
Hi, Uday.
Yeah.
Oh, thanks. One of the big elephants in the room with high myopes and high hyperopes is the difference in the strength of the lens compared to what's written on the package.
Right.
Because the manufacturers have a wide range of tolerance that they're allowed to produce. So what is a 2 diopter lens could be a 2.5 diopter lens. How do you mitigate for that within the AI program?
Right. So we have to obviously count on the manufacturer being, even if there is a variance, reasonably accurate within their range. So like I showed you, I get better calcs if I just use one company's platform and then do all my calculations based on that one platform. But you're right, there can be a difference in power. But on a high myope, a 2.5 diopter lens is functionally the same as a 2 diopter lens, right? It's really not going to have that much difference in this ultra long eye. And so, yeah, there is variance in labeling of the lenses. In the US, it's reasonably close, but you can never know exactly what the manufacturers are producing.
Yes, sir.
For AI, we need so much of data, but for the uncommon eyes, where do we get the data?
Well, that's what I said. We have crowdsourced 1 million eyes of data. So when you have, say, I have a patient who has a 44 cornea, but a 34 axial length. I only have very few of those in your data set. Well, then we can use the whole library. We can use all surgeons' data. That's the beauty of it, crowdsourcing huge amounts of data. So now when you have a very unusual eye of a 20 millimeter axial length and a 49 cornea, that's so crazy. I only see one of those a year. But on the data set, I got 1,000 eyes of that.
So
Is it a free platform or?
Right now it's free, IOLcalc.com.
it's a free platform. So now what we have to understand here is a very important message given by Dr. Uday is for any patient, you're not going to rely only on your biometry value. The 0.5 diopter variation, what he showed, that's a residual diffraction, what you're getting. It's a huge chunk. It's going to be translated into millions of patients, and patients are not going to accept that because the more usage of premium intraocular lenses and some stuff adds to that. The another big issue here is the extreme of the eyes, high hyperope, high myope both. The second is post-refractive surgery patients. They are also on the rise. Post-macular pathology patients. So all these things, you will not have a substantiate a degree of precision when you calculate with your standard biometries. Now companies like Zeiss, Biotech and all those people, they are coming with their own standardized formulas. But that again here, opens up a huge chunk of block, because you will have to use customized lenses either made by them or their preferred lenses, which we don't want the case. So here comes the usage of this kind of open platforms, where you have data available for all the possible intraocular lenses and the choice remains yours. The second major advantage which I have learned from Dr. Uday is toric IOLs. There is a game-changing platform for this calculations on toric IOLs. Your thoughts on that?
Yeah, obviously, treat the full refractive error, not just spherical. And the IOL power, we just think of spherical, but we also need to think of toricity, of the astigmatism.
Yes, so that is also one of the areas where the calculation was always a challenge, and these kind of formulas are going to give you a value add on that. So this thing should be kept in mind, and I think we will be hearing from you time and time again.
Well, at some point this will all be integrated into your machines.
Yes.
At some point it'll be fully integrated. IOLcalc.com is free for now.
Yes.
So, but again, our patents were just issued. It took a long time. It took 9 years to get the patents done. So.
Yeah, we have some more questions from the audience.
Okay, as many as you want. You're the boss. I'll take.
I started using IOL calcs 7 years ago.
Okay. Next question.
Great talk, Dr. Devgan, as always. Just wondering, did this software require any sort of regulatory approval in the US?
So we're getting to this now. So obviously, like you go to the ASCRS post-refractive calculator, there's no regulatory approval here. Ultimately, it's up to the surgeon to choose your IOL. Online, you have your toric IOL calculators, right?
Right.
So the we're just giving you what our calculation is. You obviously, at the end of the day, have to use your judgment as a surgeon. You do what's best for your patient.
So more like a clinical assist tool, so it wouldn't require any sort of a regulatory approval then?
Again, certain things may, and we're still evaluating all that. This is just a nascent field. Our patent was issued last month.
Got it.
And so
Thank you so much.
I check back with me in a year, I'll tell you more. Because today I don't know enough to tell you.